Okay, so 2019, question 2, complex numbers. I'm just going to go through the whole thing because it'll help with my full explanation, really. Okay, so complex number Z1 is equal to 2 plus I, where I squared is equal to minus 1, blah, blah, blah. In other words, we're dealing with complex numbers. And it's shown in the Argand diagram below. So Z2 is equal to 2 times Z1, so find the value of Z2. Plot and label it on the Argand diagram. Okay. So 2 times Z1, so 2 times 2 plus I, which gives me 4 plus 2I. Okay, and then we can plot that on our Argand diagram, go across to 4, and then go up 2 in the I direction, and we end up with this here. We're going to label that Z2. Part 2 says Z1 hat is the complex conjugate of Z1. Write down the value of the conjugate of Z1 and plot and label it on the Argand diagram. Okay, so if we recall, the only difference between Z1 and its conjugate is that we change the sign on the imaginary part of our number. So instead of 2 plus I, it'll be 2 minus I. So plotting that over here, I go across to 2 and I go down negative 1 in the imaginary direction, which we're going to call Z1 hat. Okay. Part 3. Investigate if the modulus of Z2 is equal to the modulus of Z1 plus Z1 hat. So we're going to create this situation. Now we know that Z2 is 4 plus 2I. So the absolute value of 4 plus 2I is the square root of the real bit squared plus the coefficient of the imaginary part squared, which comes out as the square root of 20, which when we put that into our calculator comes out as 2 root 5. Okay, so this is the modulus of Z2 that we have just found. Now we're going to do the Z1 plus Z1 hat part. So to find the absolute value of Z1 plus Z1 hat, that is equal to the absolute value. Well, Z1 was 2 plus I, and we're adding its conjugate to it, which is 2 minus I. So we've left the lines either side because we've yet to do this square root thing to it, but we know that we are about to. So that is equal to, well, 2 plus 2 is 4, and I, take away I, disappears, it's gone, so it's just the modulus of 4, which in this case is the square root of 4 squared, and the imaginary bit, there is no imaginary bit, so it's just going to be 0 squared. And that's just going to come out as 4 as our answer. So we were asked to investigate if these things were equal. For the first one, for Z2, the modulus of Z2, we got 2 root 5. For the modulus of Z1 plus Z1 conjugate, we got 4. So they're clearly not equal. So 2 root 5 is not equal to 4. So therefore, Z2 modulus is not equal to the modulus of Z1 plus Z1 conjugate. And that's it done. Going on to part 4. We were asked to show that Z1 is a solution of this equation here. There's two ways of doing it. Okay, so I'm going to do it what I believe to be the most instinctive way to do it, which is to see if I put this in for Z1. So sorry, if I put this in for Z, will I get the correct answer? So it'll be a solution if when I put this number in here instead of Z and I get 0 as my answer, then that means it works. So that's what we're looking for. So the value of Z to which we will get 0 as our answer for this here. So instead of Z squared, I'm putting in 2 plus I, and I'm squaring it. And instead of Z in the 4Z situation, I'm putting in 2 plus I as well. So I'm putting 2 plus I in everywhere I see a Z. And we're just going to state that it's equal to 0. This is one of those things that we're going to prove it by working out the left-hand side independently of the right-hand side. And hopefully we'll end up that the left-hand side is equal to the right-hand side. Okay, so we're going to end up with, remember when I'm squaring a bracket, that means multiply the bracket by itself. So 2 plus I multiplied by 2 plus I. Minus 4 times 2 is minus 8. Minus 4 times I is minus 4I. Plus my 5 is equal to 0. So we're going to expand this here. Two times 2 is 4. 2 times I is 2I. I times 2 is 2I. And finally, I times I. I times I is I squared. Minus 8 minus 4I plus 5 is equal to 0. Okay, so let's tidy up what we can. Well, I've got 4 take away 8, which is minus 4, plus 5, which is 1. So again, if you've got any doubts about that, just plug into your calculator. 4 take away 8 is minus 4, plus my 5 gives me 1. Now I'm going to add up all my i's. 2I plus 2I is 4I. Take away 4I leaves me with nothing. And I've got an I squared here as well, which can't be added to anything at this moment in time. So I've got 1 plus I squared, and we are hoping that that's going to be equal to 0. Notice that we just kept the equal to 0 all the way down, and we're only really changing the left-hand side as we work it out. Now I squared, if you recall, we know that I squared is equal to minus 1. Okay, we were told that in the question at the very, very start, but also we should be aware that I is equal to the square root of minus 1. So therefore I squared is minus 1. Okay, so this is something that I'm hoping that we know going into our exam, that I squared is equal to minus 1, and that we always have to change it into that. So that means I got 1 plus minus 1. 1 plus minus 1 is the same as 1 minus 1. Again, you can plug into your calculator and find out, but you will get 0 as your answer. And because 0 is equal to 0, that means yes. But therefore, Z1 is equal to 2 plus I is a solution, which is what the question was asking. So that is possibly the preferred way of doing it. There is another way of doing it, which I'm going to do just down here in the blank space that we have. And I'm going to do it in, I'll do it in green. Okay, so we were looking for Z squared minus 4Z plus 5. Okay, so the other way of doing this is trying to solve this like a normal quadratic. Now, to solve a quadratic like that, we would use the minus b formula. So z is equal to minus b plus or minus the square root of b squared minus 4ac. And that is all over 2a. So z is equal to minus, well, my coefficient of z is minus 4, so b is minus 4, plus or minus the square root of minus 4 squared minus 4 times A is 1, C is 5, all over 2 times my A, which is 1. Okay, now if we were solving this in a typical algebraic context, we would plug this into our calculator and we would hit equals. Unfortunately, if you do that now, you're going to get a math error. Okay, and that's because we're dealing with complex numbers here, so we would expect to get a math error. So when you're solving these as part of complex numbers, you must work them out bit by bit, because that will show you where your error is. So z is equal to, well, minus 4 is 4, plus or minus the square root of minus 4 squared is 16, and minus 4 times 1 times 5 is minus 20. That's all over 2. So then if we simplify that down, I get 4 plus or minus the square root of 16 take away 20 is minus 4. And this is where our math error is coming from. We're trying to find the square root of a negative number, which we can't do. But that's why we have complex numbers in the first place. Okay, so if I continue to work down, I am running out of space, but I'll work over to the side in a second. So z is equal to 4 plus or minus. Now, remember what we do whenever we've got the square root of a negative number for complex numbers. We take out the minus 1. So I can break that down to the square root of 4 multiplied by the square root of minus 1. And that helps because that means I have that z is equal to 4 plus or minus, the square root of 4 is 2, and the square root of minus 1 we know as I, so I've got my complex number there, over 2. Now, I can now divide 2 into both of these, because both of these are trying to be divided by 2, so we'll divide them by 2. 2 into 4 goes 2, and 2 into 2i goes I. So that means I've got two possible solutions to z. One, that z is equal to 2 plus I, or that z is equal to 2 minus I. Okay, now the question that we were asked at the start was to investigate if z1, which is 2 plus I, is a solution. Well, yeah, it just crashed. Okay, so, sorry, we were trying to investigate if z1, which is equal to 2 plus I, is a solution. Well, we've just shown what the two solutions are. We've shown that the two solutions are either that z is equal to 2 plus I is a solution, or z is equal to 2 minus I is a solution. So both of these are solutions. One of them is the one that we were trying to prove. So we've shown it as a solution by finding it as one of our solutions. So therefore, z1 is equal to 2 plus I, which is what we found just there, is a solution. Now there's two big differences between those two solutions to the one question. The second one, more mathematically pleasing, shows a full understanding of our mathematics, but does not get us any more marks than the first one. So we do recommend the first one as far as what we're looking for. Okay.